Hello student, hi, good afternoon. So today we are going to see the question number 61. Okay, so this is 61 and this question is about delay line canceller. Okay, so delay line canceller. So question number 61. This is our question number 61 and it's asking about which of the following statement is not true about delay line canceller. Delay line canceller. Delay line canceller. Which of the following statement is not correct? First of all, we will see what is delay line canceller. Okay, so what is delay line canceller? We will discuss this, and after that we will see the option which one is correct. Okay, so now see here delay line canceller. Okay, so delay line canceller. What is this delay line canceller? First of all, delay line canceller is nothing but delay line canceller is nothing but that we use in MPI radar. Okay, MPI radar. So MPI radar. So delay line canceller, this is used in MPI radar. Okay, so MPI radar. MPI radar. Delay line canceller is used in MPI radar. Okay, MPI radar. Which MPI radar? So we can write like this here. Delay line canceller. Delay line canceller is used in MTI radar. Okay, MTI radar. Delay line canceller is used in MTI radar. Okay, so which eliminate which eliminate which eliminate clutter, clutter due to which eliminate clutter that is due to stationary target and ground object. Okay, so ground object. So the delay line canceller that we used in MTI radar. MTI radar is nothing but what is MTI radar? MTI radar is nothing but it is a moving moving target indicator. Yes, moving target indicator. Okay, so MTI radar is nothing but moving target indicator. Okay, so moving target indicator. So now this delay line canceller that we used in MTI radar, which eliminate what clutter due to a stationary target and ground object as well. Okay, so now what is this clutter? So clutter is nothing but, if you see now clutter, what is clutter? What is this clutter? See, clutter is one type of what? Echo signal. Okay, so clutter is a type of echo signal. So this is unwanted echo signal. Okay, so it is a type of unwanted. It is a type of unwanted echo unwanted echo signal. Okay, unwanted echo signal which will get which get okay which get added with original which get or added with original. Okay, original echo signal which get or added with original echo signal that is reflected from the target from the target toward radar receiver, radar receiver, radar receiver. Okay, so now if we see this clutter is nothing but it is a type of unwanted echo signal, so that will get added with original echo signal which is reflected from the target toward radar receiver, and hence it what it affect the performance of echo signal. Okay, performance of echo signal that is received from what, that is received from the target, okay, toward the radar receiver, radar receiver. So this is about delay line canceller, so now let us see how this clutter will affect the echo signal which is reflecting from target toward radar receiver. So okay, so let us see if there is my target. Okay, so here is my target. Okay, so this is like aeroplane. Okay, so now there is target, and here is what, here is if you see here, this is what radar antenna, transmitter and receiver. Okay, transmitter and receiver. So this is my transmitter and this is my receiver. Okay, so now when this transmitter is what, transmitting the signal in the form of electromagnetic wave. Okay, so em wave in the form of em wave toward this target. Okay, toward this target. Now when this signal will get, okay, so when this signal will get radiated toward this target, then this signal will get reflected back. Okay, then some amount of signal will get reflected back. Okay, toward the radar receiver. Now here there is a some stationary object, like if you see the mountain. So there is a some mountain and there is a some tree is also there. Okay, so tree is there, mountain is there, tree is there. Okay, so there is some mountain, tree, and and there is this like oceans, water. So due to this what, this signal will pass through this stationary object. Okay, so due to this what, stationary target. So these are like stationary target and ground object like mountain. Yes, so these are like trees and oceans. This, when this signal will get reflected back, this is my actual what, echo signal. This is my echo signal. So this is my echo signal. When this echo signal will get reflected back, and it will what, it will pass through this stationary object. Okay, so now this signal will get scattered. And after that, so then after that it will get reflected toward receiver. So now when this signal is coming toward receiver, okay, receiver of this radar, then this signal is not original signal. Okay, so let us say the echo signal, that is received signal is what, that is my received signal is PR. Okay, so some echo signal will get added here. So this is my original echo signal. Okay, so let us say this is my original echo signal plus e dash. So this e dash is nothing but what, this is my clutter. Yes, this is my clutter. Yes, clutter is nothing but it is the unwanted echo signal that will get added with the original signal. Okay, so which will affect the performance of this echo signal. Okay, so that is which is reflected back toward the radar receiver, because the information that is contained, because the original information about this target which is contained in this echo signal will get affected by this unwanted echo signal that is due to this stationary target and ground object. And This signal is nothing but, this is nothing but clutter. This is what? Clutter. Okay. So clutter is nothing but, it is a unwanted echo signal. Unwanted echo signal which will get added with the original echo signal, which is reflected from the target toward the radar receiver. Okay. So therefore, whatever the information that is contained in original echo signal will get affected. Okay, so then we will not get the original information about what? Target. So for that purpose, for this purpose, what we are using? We are using the delay line canceller. Now this delay line canceller that is used in the moving target indicator. What? Moving target indicator. Okay, so moving target indicator use the delay line canceller. Okay, so delay line canceller, and it will eliminate this clutter. Okay, so this signal, so this will remove this clutter, and there is remaining original. Okay, so the signal will become original. This is what echo signal. Okay, echo signal. Now this MTI moving target indicator, this will eliminate this clutter. Okay, this clutter. Now what is the basic principle behind this moving target indicator? The basic principle of this moving target indicator is that it will compare what? It will compare the received set of signal. Okay, it will compare some received set of signal at present time. Okay, so it will compare the received set of signal at the present time with those signal that has been received in the previous sweep. Okay, so this is what MTA radar basic principle. Okay, basic principle that it compare the received set of signal with those signal that has been received in the previous sweep. Okay, so then those signal which are not changing their phase, and their phases remains what? Same. Then they get cancelled out by this MTA radar. So therefore, the stationary, these are what? Stationary. Yes, stationary target and ground object. Yes, stationary target and ground object, they will what? They will provide the constant phase. What? They will provide the constant phase in every cycle. So therefore, every cycle, while the target is moving, they will what? They will provide the same phase. Okay, so phase is not changing. So therefore, the MTA radar will get this, will cancel this signal. Okay, so this clutter signal. Okay, clutter signal. So therefore, clutter signal. So when the target is moving, these stationary target and the ground object, they will what? They will provide the phase which is remains constant in every cycle. So therefore, by that way, this moving target indicator will cancel out this phase. Okay, cancel out those signals which has same phase in every cycle. So in this way, this moving target indicator eliminate this clutter, and we will get the original echo signal, where we will get original information about what? Target. Okay, so this is about the delay line canceller. If you see the option A, it eliminate the DC component of the fixed target. Yes, it eliminate the DC component of fixed target. This fixed target and ground object, they will what? They will provide what? DC signal as a DC, because their phase is always constant in every cycle. So therefore, they will get cancelled out. Okay, so they get cancelled out by MTA radar, and it will pass the AC component of the moving target. Okay, it will pass the AC component of the moving target, and this delay line canceller is used in MTA radar. And this MTA radar will what? This MTA radar will reject any moving target. This MTA radar also reject any target which is any moving target whose Doppler frequency happen happen to be the same as that of what pulse repetition frequency. Okay, if what Doppler frequency, if some target, what if some target is what moving, yes, if some target is moving, okay, so moving, if some target is moving, their Doppler frequency is fd, and this Doppler frequency happen to be the same as that of what pulse repetition frequency, what pulse repetition frequency. If this Doppler frequency is equal to what multiple of this pulse repetition frequency, and that time what this multiple, this moving target indicator will what will cancel, okay, will reject this, will reject what, will reject this moving target. Okay, so will reject this moving target, means what, means MTA, means MTA radar, it will eliminate any moving target, any moving target whose Doppler frequency happen to be the same as that of pulse repetition frequency. Okay, so pulse repetition frequency, and therefore the delay time, the maximum delay time that we get in case of moving target indicator by this delay line canceller is nothing but Td is equal to what, delay time, Td is equal to 1 by PRF, 1 by PRF, yes, 1 by PRF. So this is about delay line canceller. What we have seen in the delay line canceller, where why we are using this delay line canceller, what is the purpose, where we are using this. Okay, so delay line canceller we are using in moving in MTA radar. What is MTA radar? It is a moving target indicator. Moving target indicator. Okay, it uses the delay line canceller through which it will eliminate the clutter. What is clutter? Clutter is nothing but it is a unwanted echo signal, unwanted echo signal. Okay, so unwanted echo signal, those signals which is obtained from what, stationary target and ground object. Okay, so when this echo signal will reflect back toward what radar receiver, that time this echo signal will pass through so many obstacles like this stationary target and ground object. Okay, so this echo signal will get scattered by this stationary target and ground object, and therefore this information will get what, will this information will get affected. Okay, so affected due to this unwanted echo signal. This unwanted echo signal is nothing but clutter. So therefore moving target indicator will eliminate this clutter. Okay, clutter by the principle that it will receive some set of what, it will receive some set of received signal, and will compare this with those signal which has been received in the previous shift. Okay, so previous shift, and those signal which are producing the constant phase which has the constant phase in every cycle get cancelled by this MPI radar. And this MPI radar also reject any moving target indicator, any moving. Okay, so this MPI radar also reject any moving target whose Doppler frequency happen to be the same as that of multiple of this pulse repetition frequency. Okay, pulse repetition frequency. So therefore for this the option is what, option number C is incorrect. Okay, the question is about which of the following statement is not true about the delay line canceller. Delay line canceller. Okay, so it eliminates the DC component of the fixed target and passes the AC component of the moving target. This is okay. And next one is it is used in the moving target indicator. This also okay. And the option number C, the time delay in one channel of the delay line canceller is 1/2 of the pulse repetition frequency. This is wrong. Okay, so because the delay time here, if you see here, 1 by pulse repetition frequency. Okay, so D is that it reject any moving target whose Doppler frequency happen to be the same as that of multiple of pulse repetition frequency. So this is all about this question number 61, which is based on the delay line canceller. Okay, so thank you very much. Okay.